You think the James Webb Space Telescope showed us prettier pictures. That's the mistake. You assume science upgrades are cosmetic. Higher resolution, sharper focus. Same universe, just HD. No, that's not how this works. Not in cosmology. Not when you point a mirror the size of a tennis court at the oldest light that still exists. Webb didn't clarify the universe. It contradicted it. And that should bother you, because you were very comfortable with the old story. You were told the early universe was small, messy, and immature. Baby galaxies, chaotic blobs, half-formed stars stumbling around in the dark. That story felt right because it matched your intuition. Things start simple, then grow complex. Civilization works that way. Technology works that way. You assume the cosmos would be polite enough to do the same. It isn't. What Webb sees, what the data insists on, is that massive, well-organized galaxies were already in place far earlier than your mental timeline allows. Not slightly early, not within error bars early, embarrassingly early. And before you reach for a sci-fi explanation, slow down. This isn't about aliens, lost civilizations, or secret cosmic resets. This is about gravity, time, and the brutal indifference of measurement. Here's the first myth Webb shattered. That telescopes are just cameras. They're not. Webb doesn't take pictures in the way your phone does. It measures infrared radiation, heat stretched by the expansion of space itself. That infrared light has been traveling since long before Earth existed, long before the sun stabilized, long before the Milky Way figured itself out. So when you look at a Webb image, you're not seeing a moment frozen in time. You're seeing the survivors of a violent filtering process. Only certain structures can exist long enough, burn bright enough, and remain coherent enough for their light to still reach us. That already biases what you think the early universe looked like. And then Webb made that bias impossible to ignore. Astronomers expected to find small galaxies first, lightweight, low-mass systems, slowly merging into larger ones over billions of years. That expectation wasn't naive. It came straight from equations, from simulations, from models that worked beautifully everywhere else. Then Webb looked back far enough and found galaxies that had no business being there. Big ones, dense ones, structured ones. Galaxies with mature star populations, significant mass, and chemical complexity that should have required more time than the universe had supposedly given them. This is where intuition dies. Because you want to say, well, maybe they formed faster. That sounds reasonable. It's also meaningless, unless gravity agrees. Gravity has a speed limit, not because it's lazy, but because space-time itself enforces rules. Collapse takes time. Star formation takes time. Heavy elements require previous generations of stars to live and die. You don't get complexity for free. Yet Webb's data says the universe paid up front. So now cosmologists are forced into an uncomfortable position. Either something accelerated structure formation beyond expectations, or the expectations were quietly built on assumptions no one questioned hard enough. That's the real break. Not a failed theory, an exposed intuition. You were trained, culturally, to imagine the universe like a movie timeline. First scene, explosion. Second scene, chaos. Third scene, order slowly emerges. That's narrative thinking. Physics doesn't care. In reality, the universe doesn't unfold. It survives. What you see at extreme distances isn't a chronological scrapbook. It's a stress test. The only objects you observe are the ones that formed efficiently, progressively, and early enough to leave a detectable signal. Everything else vanished into darkness. So when Webb shows you a massive early galaxy, it's not saying this is typical. It's saying this is what winning looks like under extreme conditions. That reframes everything. Time, in cosmology, is not a smooth flow. It's a filter imposed by expansion, energy thresholds, and detection limits. Looking back doesn't mean watching a clean origin story. It means catching glimpses of what refused to fall apart. And this is where sci-fi intuition fails spectacularly. Sci-fi loves gradualism. Civilizations rise. Empires expand. Complexity builds layer by layer. The universe doesn't have that patience. Gravity doesn't wait for elegance. It amplifies differences. Slight density variations snowball into domination. Early winners don't just grow, they monopolize. So the idea that the universe had to start simple is emotional, not physical. Webb didn't discover that galaxies formed early. It discovered that your definition of early was meaningless without understanding the selection effects of observation itself. Now zoom out. This isn't just about galaxies. It's about how modern cosmology actually works. For decades, the prevailing model, cold dark matter, expanding space-time, dark energy accelerating everything apart, fit the data beautifully. It still does. But models don't fail all at once. They fray at the edges. Webb didn't tear down the framework. It pulled on a loose thread and refused to stop. Because once massive galaxies appear too early, you're forced to ask uncomfortable questions. Is dark matter behaving differently at early times? Are star formation efficiencies miscalculated under primordial conditions? Or is the timeline itself being misinterpreted because light doesn't care about your sense of sequence? None of these questions are comforting. That's the point. This is what real science looks like when it's working. Confident theories meeting inconvenient measurements and losing the argument. And notice something important. No one panicked. No one reached for fantasy. The response was calculation, recalibration, and more observation. Because imagination is cheap. Data is not. Webb didn't break the universe by revealing something shocking. It broke the illusion that our intuition had ever been in charge. And if galaxies, entire star cities containing hundreds of billions of suns, can form faster and earlier than your instincts allow, then what do you think happens when we stop talking about objects and start talking about space-time itself? Because once you accept that structure, time, and visibility are not aligned the way you assumed, the next realizations get uncomfortable very quickly. You still think your intuition has range. You assume the breakdown stops at galaxies, that once you zoom out far enough, things get abstract but manageable. You tell yourself, sure, space is weird, but time still ticks forward, gravity still pulls, reality still behaves. That confidence is adorable, because the moment you leave Earth-scale thinking behind, the universe stops cooperating with your senses entirely. Start simple. You believe time is universal, one clock, one flow, same everywhere. That's not ignorance, that's survival bias. On Earth, time behaves politely enough for your brain to pretend it's absolute. Physics never agreed. The only reason you think now exists is because gravity is weak here and speeds are low. The moment either of those change, time fractures. Quietly, relentlessly. And James Webb forces you to confront this because it doesn't just look far away, it looks deeply relativistic. When Webb observes a galaxy billions of light years away, you imagine yourself peering into the past like flipping through cosmic photo albums. But light doesn't carry timestamps. It carries energy stretched by expansion, worked by gravity, and filtered by space-time curvature. You're not seeing when something happened. You're seeing what survived a relativistic obstacle course. Now let's dismantle another assumption you didn't realizing you were carrying. That distance is passive. You think space just sits there, waiting to be crossed. No. Space expands, actively, aggressively. It stretches wavelengths, dilutes energy, and erases information. Which means when Webb sees something extremely distant, it's not just far away, it's from a region of space-time that has been racing away from you since before Earth formed. That breaks the mental movie timeline you keep relying on. Because if space-time itself is expanding, then earlier doesn't mean closer to the beginning in the way your intuition wants. It means closer to conditions that no longer exist, and that's a problem for storytelling. Now, let's escalate properly. Imagine two identical clocks. One stays on Earth. The other rides along with a galaxy Webb observes near the edge of the observable universe. You want them to disagree slightly. A little drift, a rounding error. They don't. The deeper you go into gravitational wells, the more time slows. The faster space-time stretches, the less your idea of simultaneity survives. There is no universal cosmic present. There never was. So when Webb shows you a young galaxy that already looks old, the problem isn't age. It's your definition of time. You assume time is a background, Physics treats it like a dynamic participant. This is why intuition collapses beyond Earth. On Earth, gravity barely dents space-time. Time dilation is microscopic. You can pretend clocks agree. Cosmology doesn't let you pretend. At cosmic scales, gravity and expansion compete. Dense regions slow time. Expanding regions stretch it. Light threads through both, carrying a distorted report back to you. Webb isn't delivering history. It's delivering a warped transmission. And here's where thought experiments stop being cute and start being humiliating. Imagine standing on a planet orbiting close to a supermassive black hole, one that formed astonishingly early, as Webb suggests many did. Time for you crawls. Outside observers watch your processes slow, stretch, freeze. Now ask yourself, when did that black hole form? From your perspective? Quickly. From the outside? Never fully finished. So which answer is correct? Physics doesn't care which feels right. It accepts both. This is the mistake people make when they talk about the early universe, as if it were a single, synchronized event. It wasn't. There was no global clock ringing at the beginning. Different regions aged differently from the start, which means complexity didn't need permission to appear everywhere at once. Some regions got a head start, not in time, but in gravitational advantage. This is why the idea of a smooth, uniform early universe is a lie of convenience. It works statistically, it fails locally. And Webb sees locally. That's the escalation you weren't ready for. You assume the universe started simple because you imagined it starting fair. Physics never promised fairness. Small fluctuations got amplified. Density variations snowballed. Regions that collapsed early didn't wait for the rest of space-time to catch up. They exploited gravity like a cheat code. And now your intuition protests. That sounds unstable. That sounds chaotic. Correct. The early universe wasn't delicate. It was violent, asymmetric, and ruthlessly selective. Order didn't emerge slowly. It erupted where conditions allowed it to dominate. Which means the presence of early massive galaxies isn't an anomaly. It's a confession that your sense of scale, human, planetary, even galactic, is irrelevant to how reality organizes itself. Now connect this back to Webb. Webb isn't just showing you objects, it's showing you what space-time allows to exist under extreme constraints. It's revealing that the universe doesn't grow up the way you imagined. There was no universal childhood. Some regions sprinted into maturity, while others stagnated. Some structures collapsed into dominance, while neighboring volumes diluted into emptiness. And because light only reports from survivors, you mistake winners for representatives. That's the final trap. You look at Webb's deep field images and think, this must be what the early universe looked like. No, this is what endurance looked like under primordial physics. And once you accept that time, gravity, and expansion conspire to erase most outcomes, the next step is unavoidable. Because if your intuition fails for galaxies, if it collapses for time, if simultaneity itself is a local illusion, then what do you think happens when we stop pretending space-time is a stage and realize it's the actor? By now, you should be uncomfortable. Not confused, not lost, uncomfortable. Because the universe you thought you understood has quietly stopped cooperating with your expectations. So let's finish the demolition properly. You still picture space-time as a backdrop, a grid, a passive arena where matter does interesting things. That idea is wrong, and James Webb made it harder to defend. Space-time is not where the universe happens. Space-time is what's happening. And the moment you accept that, black holes stop being exotic objects and start being warnings. You were told black holes are formed when stars collapse. That's technically true and completely misleading. What actually forms is a region where space-time curves so aggressively that your concepts of distance, duration, and causality stop behaving independently. Black holes are not objects in space. They are failures of space to remain intuitive. Now here's the part Webb made impossible to ignore. Supermassive black holes existed very early, far earlier than they should have, if you believe growth is gradual and polite. These weren't stellar leftovers slowly feeding over eons. These were monsters, millions to billions of solar masses, already anchoring galaxies when the universe was barely out of its opening act. Again, Your instincts protest. How could something so massive form so fast? That question assumes time means the same thing everywhere. It doesn't. Near extreme gravity, time doesn't just slow, it loses relevance as a universal parameter. Growth near dense space-time is not linear. Accretion doesn't obey your mental stopwatch. So when you ask, how long did it take? Physics asks, from which frame? Webb doesn't answer that question. It exposes why you shouldn't have asked it that way. And this is where dark matter enters, not as a mysterious substance, but as a structural necessity. You imagine dark matter as invisible stuff floating around, gently holding galaxies together. That's a cartoon. What dark matter really does is reshape the gravitational landscape early, providing deep wells where structure can collapse violently and efficiently. Without dark matter, early galaxy formation is slow, fragile, and sparse. With it, the universe becomes ruthless. Webb's observations suggest that these wells may have been deeper or behaved differently than expected in the early universe. That doesn't mean dark matter is wrong. It means your assumptions about its role may be provincial. Cosmology is discovering, again, that elegance is optional. Now let's go deeper, earlier than galaxies, earlier than stars. You like to talk about the beginning, the Big Bang, a moment, a singular event. That language is dangerous. The Big Bang is not an explosion in space. It's the expansion of space itself, from a state so hot and dense that your equations stop being polite. There is no center, no edge, no before in the way your brain demands. And Webb is peering uncomfortably close to the limit where our current physics stops pretending to be complete. When you see light from the earliest galaxies, you're approaching the era where space-time was smoother, hotter, and far less differentiated. The universe was not empty waiting to be filled. It was already full, already structured, at quantum scales. So when you ask why complexity appears early, the deeper answer might be that simplicity was never the default. Your intuition wants a clean slate. Reality may have started with texture. Quantum fluctuations stretched to cosmic scales, seeded differences that gravity amplified mercilessly. That means the early universe wasn't uniform. It was pregnant with asymmetry. And asymmetry breeds structure. This is why understanding the universe does not mean building a neat story. It means identifying which intuitions survive contact with measurement. Webb doesn't tell you what the universe means. It tells you which explanations are no longer allowed, and the list is growing. You can no longer claim galaxies needed billions of years to organize. You can no longer treat time as a universal ruler. You can no longer pretend space-time is a stage rather than a participant. Most importantly, you can no longer assume your brain evolved to grasp any of this naturally. That's the quiet humiliation Webb delivers. The universe is not obligated to feel reasonable. It only needs to be consistent with itself. And now, at the edge of observation, consistency itself is being stress-tested. Because if early structure formed faster, if gravity sculpted space-time more aggressively, if dark matter shaped outcomes more decisively than expected, then the final question isn't what happened. It's what else are we misinterpreting because it feels right. And that question doesn't stop at black holes or dark matter. It comes back to you, your place, your perspective, your assumption that understanding the universe makes you central to it. Webb suggests something colder and more accurate. You are not the audience. You are a late arriving byproduct. And the universe was already very busy before you ever looked up. By now, you should have noticed something unsettling. The universe didn't break when James Webb turned on. You did. Not emotionally, cognitively. Because the deeper Webb looks, the more it reveals a pattern you were never warned about. The universe does not reward intuition. It punishes it quietly, with data. You grew up thinking understanding meant familiarity. That if something made sense, you were getting closer to truth. That's backwards. In cosmology, understanding means surviving measurement. Every comforting picture you carried, slow growth, orderly timelines, clean beginnings, failed not because it was stupid, but because it was human. Your brain evolved to throw rocks, track shadows, and survive predators, not to interpret space-time under extreme curvature. Webb doesn't care. It doesn't argue. It doesn't persuade. It just measures and lets your favorite ideas embarrass themselves. You thought the universe eased into complexity? It didn't. You thought time marched forward evenly? It never has. You thought space was empty until things happened inside it. Space was the thing happening. And now comes the final reframing, the one people resist the hardest. You keep asking what Webb tells us about the universe. That's the wrong direction. What it really tells you is what kind of creature you are. You are not a neutral observer standing outside reality, watching it unfold. You are embedded inside a very specific slice of space-time, optimized for a narrow range of conditions, peering outward through instruments that barely compensate for your biological limitations. Your perspective is local. Your intuitions are parochial. Your sense of natural is provincial. The universe doesn't scale down to meet you halfway. When Webb shows galaxies fully formed absurdly early, it's not taunting you. It's reminding you that history is not obligated to feel linear from the inside. When it shows black holes already massive before your mental clock says they're allowed to be, it's not creating mystery. It's dissolving a false constraint you didn't realize you imposed. And when it forces cosmologists to reconsider timelines, formation mechanisms, and foundational assumptions, it's doing exactly what good instruments are supposed to do. They make ignorance precise. Here's the cold truth you don't get from sci-fi or pop science. The universe does not unfold toward understanding. Understanding is something you chase after the fact, and you only keep the pieces that survive collision with reality. That's why Webb feels disruptive. It didn't reveal chaos, it revealed efficiency. Gravity doesn't wait. Space-time doesn't explain itself. Complexity doesn't ask permission. The early universe wasn't a blank canvas. It was a high-pressure environment where only the fastest, densest, most aggressive structures endured long enough to matter. And you, standing here billions of years later, mistake endurance for intention. That's the final illusion to let go of. The universe is not trying to tell a story. It's not building toward meaning. It doesn't care that you arrived late and curious. It simply is, and occasionally allows itself to be measured. James Webb didn't give you answers. It narrowed the list of lies you're still allowed to believe, and that's as close to truth as cosmology ever gets. You're not here to feel safe about the universe. You're here because, against all odds, a small pocket of space-time produced something capable of realizing how little it understands. That's not comforting. That's accurate. And the universe will keep being exactly what it is, whether your intuition survives the next observation or not.